हेलो बच्चों, कैसे हो आप लोग? In this class we'll going to understand contact forces. In the last few videos we'll try to understand the Newton laws of motion, right children? Yes sir, some of the videos Newton laws of motion we covered in Nlm. Some parts of Newton laws like free body diagram, contact forces we discussed. In this class we're going to study more about the contact forces and we're going to solve some of the worksheet problems on contact forces, right children? See, what is this first of all the contact forces means? Suppose one solid is moving on the surface of another solid, there existing opposing force. Okay, that opposing force we're going to study like a friction. Okay, children, this is the we can divide the force into basically two types of the forces we can able to do. One is contact forces and the non-contact forces. Okay, non-contact force like contact forces means like frictional force. Friction will arise only when two surfaces are sliding each other. Or suppose I want to hold the pen, definitely I need to make contact, then only I can able to lift the pen, right children? So this is a kind of contact force. So that is muscular force is a contact force. Okay, and tension, if something is holding on the suppose some stand, okay, we just to support some mass on the string, so tension will be acting on the string, that is also a contact force. So all these are contact forces what we call. Okay, and if a body is sliding, okay, or else the body is resting on the table, the contact between this floor and the table, there is a contact. Because of that contact, weight is acting downwards and the normal reaction is balancing that force. That kind of forces will be there. So that and all comes under contact forces. So in case of contact forces, we're going to discuss how you're going to write the free body diagram and how you're going to solve the problems that is discussed in this class. So let us see here. A force exists when two solid surfaces are in contact. See, when two solid surfaces are in contact, the force exists, and that force what we call as a, okay, this force is called as a contact force. Understood children? What is contact force? The contact force arises when two surfaces are in contact. That is, surfaces must be solid. Okay, that time you can call it as a contact. Yes. Next, the component of reaction is purpose. So we can divide the force into two components. The force we can divide because force is a vector quantity, right? So vectors always we can write in terms of their components. So two components we can, horizontal component and the vertical component. So horizontal component and vertical component. So we can divide the force into two components. Horizontal component what we call as a frictional force, right children? Horizontal component is as called frictional force and the vertical component is called as normal reaction. Normal reaction. Okay children, what is contact force? You cleared? And the force we can divide into two types. So this is the resultant force. The resultant force we can divide it into two components, horizontal and vertical component. So horizontal component we can call it as a frictional force. Vertical component we call it as a normal reaction. And the force which is resultant is called as a reaction force we can call. Okay children, the R is a reaction force. So it is like a hypotenuse. So children, this is the base, imagine, and this is the height, and the R is there, no? The resultant, we can take a resultant R here. Or I'll just imagine, suppose this N we're going to brought here, children. It is like a this triangle where F is there down and N parallelly taken this side. So this is N and this is a hypotenuse side. So how to find hypotenuse side, children? The side square plus side square gives you hypotenuse square, right? So that is only we wrote here. Here this is a N, okay, N, and this is F. So N square plus F square, okay, root of N square plus F square gives you the resultant or reaction force. Very important while solving the problem, they asked you to find the reaction force. They provided normal reaction and the force, frictional force they were going to give. Understood children? See, friction always opposes the relative motion of one surface over the another surface. Friction not always opposes the motion. Sometimes it will support the motion also. Suppose you want to walk forward, right children? In Newton third law we learned, when we want to move forward direction, when you press the in the down, suppose imagine this down in this angle with an angle of 45 degree or some inclination, you're going to press the ground. So that reaction force will come. No, this reaction opposing force also we divide into two types. One is horizontal component, okay, F cos theta, and one is vertical component, F sin theta. Where vertical component, suppose you are standing like this, vertical component is balanced by your weight of the body, and horizontal component of friction that will helps us you to move forward direction. Understood, children? So friction will be helps us to move forward also. That means friction not opposes always, friction supports the motion, but friction always opposes relative motion. Try to understand this word is very important. Friction always opposes only relative motion, not motion. It will support the motion, sometimes it will opposes the motion also. That's why we use the word relative. With respect to what it is relative, with respect to it is moving or not, so that's the term what we call as a relative. Understood, children? Next one. Friction may opposes or supports the motion of the body. Okay, so example, a person is able to walk on the ground. No, that is in case in that condition, the foot slightly will put back. That will be helps us to motion. And when a ball is rolling on a rough surface, it stops after some time because of the friction. It will opposes the motion. When ball is rolling on the ground, it will move some distance. It will stop. Why it will going to stop? Some opposing force is acting. That force friction is only that opposing field. So that ball will going to stop. That means in that condition it will opposes the motion. But when we are walking, we are just put the legs slanty, so that vertical component, okay, so the horizontal component of the friction helps us to move forward direction. Okay, this is the friction supports also and friction opposes the motion also. But friction always opposes relative motion. So 3 parts you need to keep in mind while solving problem. It must be helpful for you. Yes, children. Next, let us see the questions quickly. Try to answer this question. If two surfaces are in contact, in synopsis we discussed, right? Two surfaces are in contact, the force developed is nothing but contact force we call. Understood, children? Next, the resultant of normal reaction and the frictional force. A resultant of normal reaction and the frictional force is called reaction force R. Right? Next, when a force try to move an object at rest, these two important things we learn in the next concepts. When a body is at rest position, how much force you applied also, body is not moving. It is still at rest only. In that condition, the opposing force will come. That will call as a static friction. Static means a body is not moving. It is at just rest only. So in that condition, it called static friction. Imagine, children, suppose one block is there and pen is there in my hand, right, children? It will be at a rest position. Now no friction is acting on this. Now I'll try to move the object, even the body is not moving, but I'm trying to apply force. That time opposing force will come. That is what we call friction. But if a body is at rest, no forces are acting on it. That time no friction only. So friction arises only when there is a applied force. Whether the body move or not move, but when applied force is there, there must be a frictional force will be there. If applied force is more than friction, body will start moving. It is less than, it's just self-adjusting. That is what we call self-adjusting or static friction. I hope this is clear, children. Next, when the body it is moving on a rough surface. Okay, when the body moves on a rough surface, then there develop a force parallel to the plane of contact. That is what we call kinetic friction. When the body is moving, okay, when the body moving, it's called kinetic. Kinetic means what, children? Just it is moving. Static means it is at rest. When the body is moving with the applied force, that time the friction is called kinetic friction. When the applied force is there, body is not moving, it is still at rest, it's called static friction. Understood, children? Two words. Next concept we are going to discuss is what are the types of all the types of friction. Yeah. Next, static friction is also called self-adjusting friction. Why? Why, children? So far we discussed, no? See, when the body is not moving, suppose imagine wall is there. How much force I applied on this wall, also wall is not moving. So where gone whatever I applied for? Suppose I applied 10 newtons on the force on the wall. Where the 10 newton gone? It is just adjusting. The wall is just trying to adjusting. Suppose imagine here 10 kg block is there, children. Okay, imagine here 10 kg block is there. Suppose if I apply the force of 5 newtons, what will happen? Just it is balancing, because we need to apply more than 10, that time only it starts moving. If apply only 5, it is not moving. But where this 5 newton gone? It is just self-adjusting itself. Okay, if I start applying 9 newton also, it not move. When applying 10 Newton, that time body just starts to move. So before what you applied up to 9 Newton, that is called just as self-adjusting. Body is adjusting himself to trying to move. That means get ready to move. No? That's what we call. It's just a self-adjusting. That's what static is called. Next, friction may opposes the motion or supports the motion. Right, children? This is a true and fast statement. It is true, and this is also true. But if they give an instead of only motion, if they give a relative, the word relative they given, then it is false. Okay? Why? Because friction always opposes the relative motion, but it will supports the motion sometimes. Like while we are walking, our wheels are rotating. In that condition, it just supports. I hope this is clear, children. Yes. Yeah. And see next questions. Yeah, see children, next questions here. Kinetic friction on a body is directly proportional to normal reaction on the body they give. What about children, kinetic friction? Just a minute. Yes, now let us see the question. How kinetic friction will be depending on the normal reaction on the body. Is this true or false? They're asking. This one. Kinetic friction on a body is directly proportional to normal reaction they give. Yes, children, let us check this question. Kinetic friction is directly proportional to normal reaction. This Fk is directly proportional to normal reaction. So normal reaction is mu mg. Okay. When a block is resting on the table, mg will be acting downward. That means weight of the block is always acting downward direction. To balance this, the normal reaction is acting. And when the block is moving on a rough horizontal surface, the coefficient of friction we call it as a mu. So that normal reaction will equal to the mu times of mg. That is nmg will come. Sorry, mu mg will come. So this kinetic friction in the body is moving means it is greater than mu mg, right? So that it will be depending upon normal reaction. Kinetic friction is more than this normal reaction or just starts moving. That's why it is true option. Okay, kinetic friction will be depending on this normal reaction. Okay, next question. A man tries to remain in equilibrium by pushing the feet against the two vertical walls. Okay, I'll just give the hint for you. Like the two vertical walls are there, children. The man is standing here. Okay, remaining in equilibrium, pushing his hands and the feet to the two vertical. So his feet also like this, two hands is supporting to the wall, and the 2 feet is also just supporting, and he is standing like this. Okay, children, this is a man who's standing, is supporting, and he's just standing on the parallel walls. Okay, he must exert equal forces on the walls, and the forces of friction at both the walls must be equal. Force of friction must be present on both the walls. So what is the correct option? See here, he must exert equal force. Suppose here one side he will push, one side is not push. That time just he will fell down. So both the sides equal force. Okay, here also equal force is going to exist. Okay, in all the places, that time he is going to balance like this. If it is not equal force, one side more, one side less force, so he is going to fall. So this must be there. Next, the force of friction at both the walls must be equal. So that is not required. So what is the force means? Maybe the force of friction, it is less or more, but he will balance it by his muscular force. So no need of friction must be same. But friction must be present on the board. Friction need to be present, but no need of that one equal. If it is not equal also, chalta hai. Okay, children? Yeah, I hope this is clear, children. The question is, so answer is 1 and 3 are correct here for this question. Okay. Yeah, next question. So children, next question given here. The normal reaction on a body and the frictional force are always perpendicular to each other. They given. See, normal reaction and frictional force is always perpendicular to each other. That is, okay children, that is a true statement. Next, angle between resultant. You observe no figure. I kept the block like this. This is a parallel contact surface. Friction is always parallel to the contact surface. Okay. and normal reaction always perpendicular to the contact surface. So there must be 90-degree angle between. So 90-degree means perpendicular to each other they are. Next, angle between resultant of normal reaction and the static frictional force with the normal reaction is the angle of friction. So this is what I given. Actually, this is the angle of friction means children. This is the resultant reaction force. So this is frictional. The angle between here to here is the angle of reaction, but not here to here. Okay, children. So that's why this statement is false. So only A is the correct. Understood, children? Here only A is the correct. Of the following self-adjusting force is, see, static friction is a self-adjusting force. Why? Because how much force we applied, suppose mass is more, we applied force is less, this is just adjusting itself to move. So that is what we call self-adjust. Static is a self-adjusting. Again, normal reaction is also weight, it is just adjusting the weight of the body. Mg, this normal reaction is also self-adjusting. And tension in the string. See, when just you suspend one block with the some tension in the string, that is balances this block, adjusting itself to not fall. When block have put more, that time it starts falling. Up to then it is just adjusting itself. So here static friction, normal reaction, right children? Static friction, Fs, normal reaction, N, under tension force, all are self-adjusting forces. So we can write here option D all for this. Okay children, I hope this is clear to everyone. Thank you. Next we'll see. Yeah, this is some solving type questions. Yeah, questions. Let us see children here what is given. Frictional force of air on a body of mass 1 kg falling with acceleration 9.5 meter square is asking. Okay, 9.5 meter per second square is what they're asking. Acceleration given. How much children? What is the acceleration? That is right. Acceleration given as 9.5 meter per second square, and you know acceleration due to gravity is how much? 9.8 meter per second square, and the mass of the block given as 1 kg. This is what the given data. Here, what is the frictional force acting on the block is the given. Because of the air, some air is exerting frictional force on the body. So what is that frictional force exerting on the block? We need to find out. Suppose imagine there is no any air, just body will fall only because of gravity. Because of presence of air, acceleration decreases to 9.5. So that you just calculate frictional force will be depending upon mg minus of ma. Okay children. So R we can write it as M, we can take common, G minus of A. Let us write values of value of M given as 1 kg and a G value given as 9.8 minus of A value 9.5. So substitute 1 into 0.8, 0.5, almost it is 0.3. So this is your answer, 0.3 newtons. Understood children? 1 into 0.3 is 0.3 newtons. This is your answer. I hope this answer C is a correct. Understood children why answer C will come? Because some body, imagine some ball is falling downwards. So what will happen when the ball is falling downwards children? See, imagine, let us take one paper. Okay. Imagine what is air friction means. Imagine one paper in this rectangular shape paper. Same paper I crumpled into like ball shape. Both you going to release in the air some certain height. Okay. So you, after some time you observe, it will fall faster. Time taken, it is falling only 2 seconds, but it will take more than 2 seconds. Let us take 3 seconds it will take. Why this extra time is taken children? Because the area is more, the friction, air friction acting, air resistance acting on it is more. Okay. So that is why the body take more time. Same thing they are asking. Friction, because what is this? Air is exerting friction on that body. Because of that air friction, it will take more time. Okay. Okay, like this, because problems will come, no, you need to solve like this. You remember the formula? The F frictional force in case of air, how it is acting? M G minus of A. Okay. Right. Next question, children. Magnitude of contact force is given by. Magnitude of contact force is given by what they're asking. See, contact force, this is the contact. Okay, frictional force, normal reaction acting, and this is the resultant, also we call magnitude of contact force. So resultant R is given by root of children n square plus f square. This is the formula, right? Hypotenuse side is looking like we can calculate opposites and adjacent square. We will get this one. So that is R is equals to n square plus f square. This is the answer B. Direct question from the synopsis. Fine. Next one. A body of mass 10 kg, right children? Body of mass given 10 kg is suspended from a fixed support. Then what is the tension in the string they're asking? Yeah. See, like this one block is there. The supported, this 10 kg block. Okay. This 10 kg block is supported from the some support on the wall. Imagine. So tension will be acting upwards. That if tension is not there in the string, then body will fall down it because of tension balanced by its weight. So weight is acting downwards because gravity, right children? W is equals to m into g acting downwards. That is balanced by tension force. So tension force will be is equals to what children? M into g. Okay. Why tension is m into g? Because this tension is balanced by this mg force, right? So tension is given by m into g. See, mass is given as 10 and gravity also, they instead of 9.8 they ask you to assume as 10. Okay, 10. So 10 into 10, how much children? 10 tens of 100. So unit of force, tension is also one kind of force only. So we can write unit as Newton. Understood? So option A is the correct answer. So remember, the formula of tension is balanced by mg. So the tension will be is equals to mg. Then only body will be hanging like this, or else it will fall down. Okay. Next, tension in the cable is 1000 kg. The elevator is, okay, tension in the cable of 1000 kg elevator is the mass of the elevator they given as 1000 kg, right children? And the tension is this much weight. 1000 kg weight is the tension. See, remember the one unit I'll tell you. 9.8 Newton, we can write it as a 1 kg weight. 1 kg weight. This is just a small conversion from force. One more unit of force is kg weight. That value is 9.8 Newton. Almost is nothing but G, value of G into Newton. Understood children? Instead of writing Newton, we can write kg weight also. Okay. Right. So let us solve the problem here. Tension in the cable this and weight is this. What is the tension children? Tension is equals to mass into gravity. Mass is given as 1000 kgs into gravity is 9.8. Right. So it will come Newton. Imagine. Okay. Tension will be 1000 into G 9.8 Newton. Now I told you this relation. See, we can replace 9.8 Newton as 1 kg weight. Understood children? 1000 into 9.8 Newton I can replace as 1 means just 1 nothing but 1 only kg weight. Understood? So tension, how much I got it as? Tension is 1000 kg weight. So they only given no tension is 1000 kg weight. That means if mass is 100 kg elevator, it is 1000 kg means it just balances. It won't fall down. Understood? If it is a mass 1000 kg, because tension is same and mass is balances. If m into g gets same value. Okay, mg is equals to tension. Okay, tension value is 1000. So left hand side, if you substitute 1000 kg weight, that is equals to right hand side. That means up force and downward force both are equal. This is comes given 1000 kg weight. Okay, children, this is what we got by calculation also, 1000 kg weight. So both are equal, so that the body will just, it will be at a rest position or it will be at a move with a uniform acceleration or uniform motion. Understood children? So option D, when body is at rest, both are equal means body will be at rest or uniform motion. Yes. Next question. If an elevator is moving vertically up, so elevator like this, no lift, it is vertically moving upward direction with an acceleration A. The force exerted on the floor of the passenger of mass m. Suppose passenger is there inside. Okay, his mass is m. In that condition, what is the force will be exerted? They're asking. When the accelerator and lift is going upward direction, along with this G, here A is also going to add up. That's what, when you there inside a lift, when you're going up above the up inside a lift, your weight will be appears to be increased. Same lift, it is coming downwards, no, it will be minus up A. That's why your weight appears to decrease. You feel weightlessness when you're coming downward in the lift. Suppose in the same lift, you need to go upward direction, that time your weight will be appears to increase. I hope this is clear, children. So answer is mg, we can split m into g plus m into a. So last option. Okay. So these questions are very important for your competitive exams. So must you learn this. Don't skip any topics. Yeah. Next one. See children, here given to keep a particle moving with constant velocity on a frictionless surface is given. An external force is not required, right? If it is a friction, suppose a ball is there, if you just roll the ball on the floor, because floor having a friction, that's why after moving some distance, ball come to stop, because friction is acting it from the opposite direction to stop the ball. Suppose imagine there is no any this force, opposing force is not there at all. So ball will be keep on moving only. Imagine the world how nice, no? If there is no friction, nobody will coming to stop. Everybody will be in motion only. Okay, we cannot imagine that. Suppose we'll stand, the stones will be keep on moving, means they will come and hit us, right? So whatever. So friction is so much advantages for us to stop unwanted bodies. Okay, and unwanted motions also. So fine. What is this question answer, children? Clear, no? If does not require any external force, if there is a frictionless surface, there is no any friction on the surface, means body keep on moving only. Okay, because of friction only, the force on that body is going to wasting and body finally becomes zero, so body come to stop. It is not necessarily required. Next, frictional force always opposes the motion. See children, this question is wrong, right? Because what I told, frictional force always opposes, the word is missing here, relative. If they give relative, then the statement is true. If only opposes motion, no. It will sometimes supports the motion also. Friction sometimes supports the motion and sometimes opposes the motion also. But always, in suppose they won't give always word, that time also it will be true statement. Or else suppose they give relative word, that time also it is true. But friction always opposes the what? Relative motion. Okay, it will suppose if they give opposes and supports the motion, that is correct. Fine. Frictional force is non-conservative force. See, what is this conservative force? Means whatever initial energy, it equals to final energy, but it is not. Because of the friction, so much energy is going to waste it. Okay, because of irregularities of the surface, the ball is rolling here to here. You can see the soles of the shoes. It's so much energy or so much wear and tear effect, you can see, no, so energy going to waste, and efficiency of the engines also going to decrease because of this friction. So much energy is going to last, but is not a conservative force. Okay, it is a non-conservative force. So only option, okay, it is a non-conservative force, right? They given correctly. It is statement B is true and E is false. It is not a conservative, it is a non-conservative force. Conservative means how much how much energy you applied initially. The initial energy is equals to final energy. Okay, that time we can call it is conservative. But it is not like that. It is initially what we applied that not equals to final, because friction will lose some amount of energy. That means it will eat some amount of energy. Right. Next question. With increase of temperature, frictional force acting between two surfaces. As the temperature increases, no children, what happens? Molecules will be keep on moving random motion. Because of this high random motion, the contact frictional forces acting on them going to decreases. So when the temperature increases, motion will be faster. It will helps to move forward. Okay, motion will be faster when having high temperature. So Opposing force is friction, right? So that it will decreases. Next, if a man is walking on a direction of friction, the direction of friction is same as the direction of motion. See, when a man is walking, imagine children, if a man is walking, suppose imagine his eyes is going in this forward direction. So slantly you need to press the ground downward direction. So what happens when we going to press, this is the action. So reaction will be in this direction. So reaction force we're going to imagine like a two components. One is horizontal component and one is vertical component. Vertical components will balances its weight and horizontal component helps us to move forward direction. That is why when we are walking, friction and opposing our motion, it will just support our motion because acting in the same direction. Understood, children? Suppose imagine there is no land. How can you walk? In the air, is it possible to walk? No. So when you push the land backward direction, then only you can able to move forward. Okay, that means when you press, there is action will go inside, reaction will be coming out. That is the frictional force. Okay, I hope this is clear. If you want to know more about theoretical physics, children, I already done theory 8th standard, one topic is there. Okay, 8th standard friction chapter is there. In that I explained theory regarding friction, how friction, different types of friction, how it will cause, what are the effects of friction, everything I explained there. So you want theory, please see that 8th standard CBSE, okay, 8th standard CBSE friction chapter. Okay, it's some friction chapter is there. I explained detail regarding friction types, everything. Once you see that, it will be helpful and it will give clear idea regarding the friction, what it means actually. Okay, with the help of PPT, I clearly explain there. It will be helpful for you. Okay, children. Next to see. Here question is, horizontal force of 10 newtons is applied on the block of 2 kg resting on a rough horizontal table. Then the normal force on the tube is applied on the block is. We need to calculate normal reaction, children. Just a second. Yes. See, I'll write here. Normal reaction formula is, children. See, any block is there here, weight will be acting downwards. Okay, what is the weight? W is equals to mg is acting downward. To balance this, normal reaction will be acting upward direction. You know, no? Newton's third law. There must be opposing force, right? When force is acting equal, their equal and opposing force must be there. So now normal reaction is equals to what, children? Mass into gravity. So mass is given as 2 kg and gravity is how much, children? It is 10. So multiply 2 into 10 is how much? 20 newtons. And which direction normal reaction acting? It is acting upward direction, upwards. So this is the correct answer. Yes, understood, children? Normal reaction does not depend upon what is applied force. It will depend only on what is the weight of the body. Frictional force depend upon applied force. Okay, this 10 newtons they applied, but it's not depend on that. It depend only on mass and gravity of the body. Right, children? I hope this is clear. Yes, see the next question. A man slide down a telegraphic pole with an acceleration is equals to 1/4. Okay, 1/4 of a acceleration due to gravity. That means g by 4. I'll write properly. A is equals to, children, given g by 4. Due to the gravity, okay, the frictional force between man and the pole is equals to, you need to calculate friction. Suppose imagine this is a pole, electric pole is there. The man, okay, just is coming down from the electric pole. Just coming down from the electric pole, like this is coming down. So his weight is acting downward. Like, children, W is equals to M into G is acting downward direction. At the same time, where the acceleration, because man is coming downwards, acceleration be in the downward direction with the what acceleration? Acceleration is equals to g by 4. Okay, 1/4 of a acceleration due to gravity, that is g by 4. I hope this is clear, children, everyone. What is that given? Yes. Now let us see the formula. What is the formula used to calculate this? So you know, a frictional force will be depending upon mass into G minus of A. Here mass and G minus of A is nothing but G by 4. Understood, children? Now take the LCM of nothing is there means 1, 4 and 1 LCM is 4 and this 4 cross multiply here 4G minus of G will come, no? So we can write 3G into mass is there. Understood, children? So this is the frictional force actually, but what we want to represent in terms of weight we need to put. So you can write this is 3 by 4 into m into g. So you know m into g is nothing but weight. So 3 by 4 into w. Clear, children? This answer is 3w by 4. Okay. So what you need to remember, the formula frictional force is given by mass into g minus of a. When it is coming downwards, G minus A. Same person, if suppose he was climbing the same acceleration, no, suppose you need to go upward direction, that time you have to put G plus of A, okay, M into G plus A. So coming downwards, minus of A. Same in case of lift, what we learned problem, same thing. Okay, next question. A body of mass 600 grams slides on a rough horizontal surface, okay, just body is a horizontal surface, one block is there, just is sliding. Frictional force of 22.2. Frictional force, how much, children? F small f is 2 newtons. This is the mass of the block. Then the magnitude of reaction force is how much? You need to calculate reaction force. So R is equals to what, children? Okay, R square you take. Reaction force is equals to N square plus F square. Understood, children? N square plus F square. But here they not given you N value. So N, where is the N? Here is the N acting upward. To balance this, weight will be acting. Weight is what? M into G acting downwards. So nothing but we can write N is equals to M into G. So here M is given as 600 grams. We need to convert it to kgs. So 1000 into G is 10. So cancel 0, 0 and this 2 zeros and 2 zeros. So what you will get value of N, children? N is equals to 6 newtons. Understood? You got N is a 6 newton. So don't confuse this N and this. This is a normal reaction and this is Newton. So write in place of N 6 square and in case of F friction given as 2 square. Understood, children? 6 square is 36 plus 2 square is 4. 36 plus 4 gives you 40. But I need to find R, not R square. Okay. So that R is equals to square root of 40. I can take R. Root of 40 does not having any perfect square. So I can split it and write as 4 into, I can write it is 4 into 10. Understood, children? 4 into 10 I can write. So root 4 I can take it as a 2 out and root of 10 there inside. So this is what your resultant force. Unit is Newton. Understood? First, here in this problem, you need to find the normal reaction. After finding the normal reaction, you got 6 Newton. That 6 Newtons you apply in this formula. So you'll get the answer. Understood? Finding N and finding R. So R is your answer as option D. Yeah. Clear, children? Yes. Next question. See. Yeah. See, children. Next question. First read the question. A block is in limiting equilibrium. Okay. On a rough horizontal surface. If the net contact force is √3 times the normal force, the frictional force is, if N is the normal reaction given. Understood, children? The problem is, okay, let us analyze. Given √3 times the normal force. The net contact force means what? It is R. Net contact force means what, children? It is R. Okay. Yes, sorry, children. One second. Yes. See, what is the given? Net contact force is given. Net contact force means R. R is given as √3 times the normal reaction. Okay, and what is the frictional force is? Okay, we need to calculate the frictional force. So you know the relation that R is equals to n square plus f square. Okay, root of n square plus f square. But you let us take r square. R square is equals to, children, what you will get, ma? N square plus f square. Given here r, given r is what given? Root 3 Newton. Substitute that only. So root 3 n whole square is equals to n square plus f square. Okay, so root 3 whole square, what we will get? 3 n square. Root 3 square is 3 only, n into square, n square is equals to n square plus f square. So we want only f square, so send this one this side. So 3n square minus of n square is equals to f square. 3 minus of 1, it is 2n square is equals to f square. Or what you will get, children, now? So n, what you need to find? F. So f square is equals to 2n square is there. Or take this square to left hand side, becomes root 2. Okay, root 2 into n. Understood? Root of this 2 is root 2, and root of this we can take it as n. So root 2n is the answer. So, okay, option A. Clear, children? So for what I discussed, yes, समझना है, not समझना है, try to listen. Okay, you definitely will get समझना है. Yeah, next question. A block is sliding on a rough horizontal surface. The contact force on the block is root 2 times the frictional force. Now, contact force, okay, children, what are given? R is equals to root 2 times the frictional force. The frictional force is what they're asking. Okay, you need to calculate frictional force only in terms of normal reaction. So fine, R is equals to what, children? It is a root 2. Okay, first write a formula. R square is equals to n square plus f square, right? Where R place you have to put root 2f whole square is equals to n square plus f square, or root 2 whole square is 2, f square is f square, okay, is equals to n square plus f square. So you want to find f square, send this f square common here, this side becomes 2f square minus of f square is equals to n square. So 2f square minus f square gives you f square is equals to what, children? Just n square. Or we want to find only f. So f is equals to what, children? So root of n is n only. Okay. So r we can write 1n, or you can write only n. So both are correct. So option D. See, this problem and this problem, only you need to remember the formula that r is equals to root of n square plus f square. So remaining terms, result reaction force, r they will give in terms of f, r in terms of f the given. So that substituting and simplification all is algebra. Only formula you need to remember here. Okay, I hope only 14 questions based on the contact force given. Okay, children, thanks for watching. In the next class, we're going to discuss static friction and the sliding friction. That problems are very interesting and that will be very important also. So keep watching for the next video. Thank you, children. Have a nice day. Try to share to your friends. Let them understand and that be helpful for them. Thank you all. Have a nice day, children. Bye.